in the measurements lab, the goals are to use measurement devices like a ruler to measure length. Let's turn this on. So we're going to use a metric ruler to measure length in centimeters. Also going to be using a beaker and a graduated cylinder to measure liquid volume, and that will be in units of milliliters. And then we're going to be measuring mass using an electronic balance, and that is in the lab, and I'll provide video. Okay, mass is measured in the lab in grams, or G. And as I mentioned last week, if you don't have the lab equipment, the beaker, the graduated cylinder, that's okay. I'll provide information for that, for the experimental data. And the metric ruler is the one thing I hope you can use. So you're going to be using those measuring instruments to gather data. That's measurement value, is data. And these are measured values that have units, like the centimeters or the milliliters or the grams. So those are examples of centimeters, milliliters, and grams. Those are units, and those are the SI units that are used in science and math to measure length, volume, and mass. Okay, so they're used in science and physics, and in Europe and in Asia. And we're also going to be doing conversions between the SI units to the English units. Those are calculations that we'll be doing in the analysis of the lab report. And then another calculation you're going to be doing is determining the density of aluminum. This is a technique of water displacement that I'm going to provide video for. I need a few other things from the kitchen, some water, and also a cube and a can. And they can be any cube, some box, or any can, soda can, or a can of soup. So when you are using a measuring instrument like this ruler, you first want to find the smallest marks on the measuring instrument. And those smallest marks usually don't have numbers next to all of them. Just like in that ruler, some of them have numbers, the 1, the 2, the 3, but then the smaller marks are in between those reference points. So the smallest marks on the measuring instrument, this ruler here, are the 0.1 place. And then the precision is usually going to be 1 place better. So 1 place better than this would be 0.01, 1 decimal place versus 2 decimal places out. So this is the tenths place that are the marks, and the hundredths place is the precision. So that means that every measurement taken using this ruler should be 2 decimal places out, 1.65, 1.66, 1.67, and 1.68. So on the beaker you're going to see, so in your glass beaker and your lab equipment, the smallest marks are actually the tens. You'll see 20, 40, 60, 80, and then marks in between there. That's the tens place. And so 1 place better than the tens place is not 10.1 or 10.01, but it's actually this, what's held by that 0. This is the ones place. So the beaker measurements, the beaker that you're going to be using today, those measurements need to be to the ones place. And so I'll draw that real quick, is that here's your beaker. And you can see this would be 10, this would look like this, it actually looks like this, 20, 40, 60, and those are the 10, 50, 30, 40, 50, 60. So the tens place, it's what are the markings on the beaker. And you can read in between the marks, if I draw what the liquid line would be here, this would be in between 20 and 30, this would be something like 25 milliliters. So that 5, underline this in purple, is the ones place, and that's the precision needs to be represented there. And the precision is important in the cases when you're measurement value falls right on a mark. So for instance, if this purple line were the liquid volume, this would be 20 milliliters, but you need to hold that ones place by making it 20 and a decimal milliliters, making that 0 significant. So you're also going to be using a graduated cylinder to measure liquid volume, and this is a little bit more precise than a beaker. You can see that a graduated cylinder, the plastic graduated cylinder you're going to use, has markings on it that look like this in this figure, where this is 25, 30, and 35. And there are 10 marks between 25 and 35, so each of these marks is a tenth of the way, holding the ones place. So this would be 25, 26, 27, 28, 29, 30, and so on. So the marks on the graduated cylinder, the smallest marks, are the ones place. And then the precision needs to be one place better than the ones place. So this is the ones place held by a 1. And this would be one place better is the 0.1 place. So this is 1 decimal place. And that represents the tenths place. So the tenths place, or 0.1, or 1 over 10. And so that means that what you can read to this, what you can read using this measuring instrument needs to be to 1 decimal place out. And so here on this graduated cylinder example, this is the meniscus, and you need to read the bottom of the meniscus, the lowest point of the meniscus, and that falls right here on this 30. And so this is 30 are the digits that are known exactly. Those are certain digits, okay? And then because this needs to represent the 1 decimal place, I'm going to add a 0.0 to hold that exactly on 30. And this makes a difference because this is 30.0 milliliters. And this makes a difference in the measured data value. This has 3 significant figures, because remember, you have the 3, those zeros are trailing zeros with a decimal, so 3 sig figs, which is different from a measuring instrument that would only measure to the ones place and would give you only 2 sig figs. So your measured data value, the measured data values, even if you didn't measure them yourself, those data values tell you something about that measuring instrument that was used to measure it. So you're going to be using a metric ruler to measure the dimensions in parts A, B, and C, in A and B. That's the shapes on page 6 of the procedure, and also the box and the cylinder. You're going to be using a graduated cylinder, a beaker, and also some measuring cups from your kitchen to measure liquid volumes in part C.